All right, it's section 2.2. The first thing we're going to do is kind of like we did on the last one. We're going to start with some sets on the left, and we want to match them to the descriptions on the right. So take a few minutes and see if you could do that. So as you're writing those down, the first one is we have set P, set Q, set P and Q, and the empty set. Okay. Which, if you want to look at that, that includes, we look at the right side, the proper subset. Proper subset doesn't include the element itself, so that wouldn't be it. Complement, we're not talking about the complement there, so it's not B or C. So D is a subset of P and Q. So subsets meaning using each of the elements. We use P right there. We use Q. Then we use P and Q, and then we also use the empty set. So D, one is going to be matched with D. Number two is P, Q. So basically it's the same as one, but doesn't include the set PQ with the elements P and Q. So it's the proper subset, because remember the proper subset doesn't have the equal to bar, right? So we said this one was D, and this one is A. Let's work out this next one. So if you have A and B, we'll have the complement. So here, if you have the universal set right here, A, B, C, and D, they tell us if A, B, and C and D is a universal set, and we include C and D. So if we include this, what would be not included? What's not the complement of that? What's not C and D? A and B, so that's going to be B right here. And the last one is the complement of U. Well, we said if U is the universal set that includes everything, well, what's the complement of everything? Nothing. So that's this. You'll get a little bit better at these as we go. And we work out some of the diagrams, the tree diagrams and stuff, and work through some of this stuff. So the next thing is we're going to just go through and determine if we have subsets. Okay. So the first question is Monday, Wednesday, Friday a subset or not a subset of Sunday, Monday, Tuesday, Wednesday, Thursday? Not. Why? Because of the F, right? Well, this has an F in it, a Friday, and the other side does not, so this is not. All right. What about the next one? The empty set is a subset or equal to because of the equal to bar. All right. -5 to 9, and x such that x is an odd integer. What messes that up? The 2, so that means it's not a subset. So we would say no. One, 2, and 9/3. But what is 9/3? 1, 2, 3. So that's really 1, 2, 3. Is that the set of rational numbers? Is that in the set of rational numbers? Yes. Okay. So our next part says we want to know whether it's a proper subset, a subset, both, or neither. So we're right here. We want to know subset, proper subset, both, or neither. So we have 9, 1, 7, 3, 5. We look over there to the other side, 9's there, 1 is there, 7 is there, 3 is there, 5 is there. They're all there. So it will have their a subset, and it has the equal to bar because they're equal. What do you think here? The empty set and the set containing 0 elements. Both, right? One or the other.
I would think it would be neither because 0 is still elements. It just has none.
Yeah, so hold on, let's see. 0 is the empty set. So up here we said 0 is equal to the empty set, so that's the case. And here you have the empty set and just the set with the element 0 in it. So yes, so this is going to be neither. All right, look at the next one. Actually, wait a minute though. The empty set, because that one is tricky. This one's always tricky. But first of all, the empty set is 0, so it has nothing in there. So it's 0. And that cardinality is 0, so yeah, no, it's still neither. Because that's an element cardinality of the one to the right is what? 1. Yeah. Alright. Those are tricky right there. Alright, the next one is Sunday, Monday, Tuesday, Wednesday, Friday. What about it? No. Alright, next. If you're given the universal set, now they're going to tell us what U is. So sometimes I told you they describe U. If not, we think it's everything. But right now they tell us what U is. And they also give us A, B, C, and D. And then they're going to ask us some true, false questions about that. we wanna know, is A proper subset of the universal set? So when we look at A, we have A and E. Are those included in the universe?
Yeah.
Okay, so is it true or false? So we would say yes, that's true. Alright, let's look at the next example. Is D a subset of B? Is it included in it or equal to it? D and B. So D is DE. And we go to the elements in there, and what do they're not there. Go check in B, they're not there, so we say false. Alright. Is the empty set a proper subset of A, first of all? And then we would say not that. So here we would say false, because in this case we'll also have because the empty set is a subset of there. So the empty set's included, so that's the empty set, then you have the A and you also have the E. So it's known to be there. So empty set is that, so therefore when we look at what was given to us, we say that's false. Alright, and then the next one is B a subset of C. So check B. B is A, B, E, F, G, and C if that is in C or equal to it. No. What about D and B? So D is DE. Is that in B? So DE, that is not in set B, so we would say false again. All right, go ahead and write these next ones down. They give us a new universal set. So each time you have a new universal set, you base your questions on that. So it's counting numbers 1 to 10. Find the complement. The complement, if you're given U, the complement is not that. So our first set is if they tell us our set is 1, 2, 3, 4, 6, and 8, we want to know not that. So we want to know everything in U that's not already listed. So basically, we just list everything that wasn't. So 1, 2, 3, 4. We start with 5, 6, 7, 8, 9. Is that everything? 10. One more. There you go. Alright. If I tell you U, what's the only way to get the complement of that? What's the complement of the entire thing is nothing. And then for the next one, if I tell you nothing, what's the complement of that? Everything, which would be U. Alright, and then the next one's easy. If they tell you 2, 5, 9, 10, we need to give everything else that's not those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then we'll finish up here. It says find the number of subsets and proper subsets. Well, we were given a formula for that. Subsets. First of all, let's count our elements. How many? 1, 2, 3, 4, 5, 6 elements. So for subsets, we would have 2 to the n, which would give us 2 to the 6, because our n is 6, which is equal to 64 subsets. Proper subsets is 2 to the n minus 1, so I would have 2 to the n and subtract 1 from that, which would just be 63, 1 less. So that you can just use your formulas to know how many. Now, this tree diagram is helpful for like when we look back hindsight to the very first description ones and it's saying how many elements are proper subsets or in those other descriptions, because now we'll have the visual for this, and you can use this tree diagram method for it. How many subsets we're going to use a tree diagram to do this. Alright, so the first thing you do is you take each element. So I have B, I have F, and I have G. Okay, however many elements you start with those across the top, and then for each element, it's kind of like the coin toss thing, right? It's either gonna be a subset or it's not. So it's either yes it is or no it's not. So for B, I have yes or I have a no option. For my first element, I have yes or no. For my second element, well, I don't know if this one was picked. So I have a yes or a no element for F, but I have to do it off of each of the previous. So yes, no. Okay, when I get to my third column, the G is it's going to be a yes or no, but I have to do yes or no off of every one of the previous from the previous. Now if we go across, we're going to name all the possible subsets that there are gonna possibly have here. All right, here we go. The first one is yes, yes, yes. So that means yes include B, yes include F, yes include G. Yes, yes, yes. The next one would be yes, yes, no. So that one would be yes include B, yes include F, do not include G. Yes include B, no, yes. So here we would have B, not F, but G. Yes, no, no. So yes, B, nothing else. No, yes, yes. So not B, but F and G. No, yes, no. Not B, include F, but not G. No, no, yes. Not B, not F, but G. And then the last one is no, 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 which, how do I describe that? Empty set. So there are how many possible 1, 2, 3, 4, 5, 6, 7, 8? 8 possible subsets, but also look if we used our formula 2 to the n with n had 3 elements, 2 to the n is 8. You can see where our formula could have told us that. But sometimes we have to tree diagram this thing out so we can see every possible set, because sometimes, like back in that multiple choice, remember they asked us about P and Q? So we had to know it included P, included U, included the empty set, and then also not. So when you're looking at these, that's going to be how you depict them, so that you can see the entire. Basically, it gives every single possibility. So if you had a set that just had P and Q, like the first one, you would have a P and you would have a Q, right? And then you do yes, no, yes, no. Or if I did this, if I had a P, Q, R, and an S, then I would have an R and an S, and I would do the same thing, but it'd be, of course, a lot further than that. Out. And this one particular problem, like, it's still, I'm not completely in agreement with this one yet. So, work with me. First of all, let's go back up real quick, and now that we have seen a tree diagram, not that, right here. So if you look at this, this is a subset of P and Q. So if I was to tree diagram it, it would be D. It means it would be P by itself, Q by itself, both of them, and also the empty set. So what we didn't realize, like every set automatically includes the empty set. So that's why I was saying something about this was bothering me, and it's kind of tricky. I don't think it can be neither, because the empty set's included in that, right? So it has the empty set, but so 0 also has 0 and the empty set. So we'll have just that one for sure. So because it has the empty set in it. But will it be equal to that? Or no? Yeah, so that one kept just bothering me because it's tricky, and I think you could kind of talk yourself into it, but we were not, just like we did when we got here, the assumption is that the empty set is an element, an assumed element of it, okay, that was the case. So go back and, check that one. Any questions about any of the rest of those? All right.